Welcome to Dan is Smart. Today we are diving into one of the most powerful tools in all of calculus, the derivative. We will start by breaking it down with the classic limit definition. Solve some examples step by step and then use it to unlock the equation of a tangent line. Stick around because by the end of this video, you will see how derivatives turn abstract math into real-world problem solving magic. Now, when we say derivative as a function, basically what we are trying to say is we have f prime of x to be equal to the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. So instead of finding the derivative of a function using the other approaches that we know, sometimes you can be asked to use the derivative as a function. Now, how do we use it? Let's consider this example. We have to differentiate f of x, which is equal to x over x minus 1 using the limit definition. So using the argument over there, now we know that our f prime of x should be limit as h approaches 0, f of x plus h minus f of x out of h. Now in this case, we have to find our f of x plus h, and also we know our f of x. So now let's find f of x plus h. F of x plus h simply means wherever we see x in our function, we have to replace it with x plus h. So in this case, we have x, so we have to replace it by x plus h, so we have this. In the denominator, we have x plus h, then minus 1. So we can go ahead to rewrite our f prime of x to be equal to the limit as h approaches 0. Now f of x plus h, we had x plus h minus 1, then minus x out of x minus 1. This f of x is what was given in the question. Then everything divided by h. So let me cut this right here. Okay, so let's move on. So now the next step is to simplify this. So we have f prime of x is equal to the limit as h approaches 0. So let's simplify the numerator. So for the numerator, we can find the LCD. So in this case, we have x plus h minus 1 and x minus 1. If x plus h minus 1 comes into this, it will cancel the first part, leaving just x minus 1. So we have to multiply x plus h by x minus 1, then minus our x. If this denominator comes over here, it will cancel just this, leaving x plus h minus 1. So we have to multiply this by x plus h minus 1. Then everything out of h. So this implies that our f prime of x is equal to limit as h approaches 0. If we expand these brackets, if we do that, we are going to have s squared plus sh minus x minus h minus s squared minus sh plus x out of x plus h minus 1, x minus 1 out of h. Now we get to see that s squared will cancel s squared, sh will cancel minus sh, negative x will cancel positive x. So we are just going to have our f prime of x is going to be limit as h approaches 0. In the numerator, we just have minus h. In the denominator, we have x plus h minus 1, then x minus 1. Everything divided by h. So you see, you can have everything divided by h, which is the same. If we want to change this division to multiplication, then we have to find a reciprocal. So the reciprocal will be 1 out of h. So in this sense, the h will cancel the h. So we have f prime of x is equal to limit as h approaches 0, the negative 1 in the exponent, in the numerator. In the denominator, we have this. So in this case, limit as h approaches 0 basically means that when h goes to 0, so this term right here goes to 0. So we have negative 1 out of. Now when h goes to 0, in the first parenthesis, you can have x minus 1. In the second one, we have x minus 1. So this is just negative 1 out of x minus 1 squared. I hope this is clear enough. So when you find the first derivative of this function using a limit definition, you're going to end up getting this. If you use any other process, you'll still end up getting that. But we're not going to talk about the other process. We are going to do it as we move on in the course. I hope this is clear enough. Let's look at a second question. Our question 2 is using the definition we have to calculate the derivative of the function then find the values of the derivatives as specified. So we have our g of t to be equal to 1 out of t squared. And afterwards, we have to find g prime of negative 1, g prime of 2, and g prime of root 3. So now let's go ahead to solve this problem. So first of all, we have to write our limit definition. So g prime of t is equal to limit as h approaches 0. Now we are going to have g of t plus h minus g of t out of h. Now remember, this is now g of t. The other one that we were solving was just f of x, right? So it's just change of variable. So now we have this. So as always, we have to find our g of t plus h. So g of t plus h basically means wherever we see t in our expression of g of t, we just have to replace it with t plus h. So in this case, we have 1 out of, now we have t, so we have t plus h all squared. So we can go ahead to substitute it into our equation. So we have g prime of t is equal to the limit as h approaches 0. Now we have 1 over t plus h all squared minus our g of t, which is just 1 over t squared, then out of h. The next thing is to simplify your numerator. So for your numerator, you just have to find the LCD. And in this case, the LCD is the two terms, right? We just have to multiply the two terms. So we have this. And if this comes over here to cancel this, so we just have t squared left. So we multiply 1 by t squared. Then minus 1, this one right here. And if t squared comes over here to cancel this, we are going to have this left. So you have to multiply everything by t plus h all squared, then everything out of h. I hope this is also clear. Okay, so now the next thing to do is to simplify it. So limit as h approaches 0. If you simplify the numerator, you have 1 multiplying t squared is just t squared. Then minus, if you expand the parenthesis, you have t squared plus 2ht plus h squared out of the denominator, which is t plus h all squared, t squared out of h. So we have our g prime of t to be equal to, now if we expand everything over, if we distribute the negative, we get t squared minus t squared. So you're just going to have minus 2ht minus h squared out of t plus h all squared multiplying t squared. Now everything over h. I hope this is also clear. So remember, if we have everything over h, you can just find the reciprocal. So there should be a limit here. So limit as h approaches 0 minus 2. So you can see that over here, there's h here, there's another h here. So you can factorize the h out. Then we have minus 2t, then minus h out of, now we have t plus h all squared multiplying t squared. All divided by h, you can write times 1 out of h. So we can see that this h will cancel this h. So in our next step, we have g prime of t will be equal to, if we multiply the numerators, we just have minus 2t minus h, and in the denominator, we have t squared times t plus h all squared. Always do not forget your limit. So we have limit as h approaches 0. So now when h goes to 0, meaning that this term right here goes to 0, this also goes to 0. So we have, in the numerator, we're just going to have minus 2t. In the denominator, we have t squared, then t plus 0. So t plus 0 is the same as t. So we have t squared right here. So this simplifies to minus 2t. If we multiply these two, we have t to the exponent of 4. Remember, indices, if the bases are the same and we are multiplying, we just add the exponent. So we have this. In this case, we have this t will cancel one of the t in the denominator. So we are just going to have minus 2 out of t cubed. So if we differentiate this expression right here, we end up getting minus 2 over t cubed. So that is our derivative. Remember, the function, after finding the derivative, we have to find, the first one was g prime of negative 1. So in this case, all that we have to do is to replace our t with negative 1. So we have negative 2 out of negative 1 cubed. So this is minus 2 minus 1 cubed. Note that is minus 1 times minus 1 times minus 1. This times this is positive 1 times this. So 1 times negative 1 is just negative 1. So we have negative 1 here. So negative 2 over negative 1 is positive 2. So this is our g prime of negative 1. B, that was g prime of 2. So g prime of 2, using the same idea, we have 2 raised to the power 3. So this is negative 2 out of, now 2 raised to the power 3 is 2.2.2. 2.2 is 4, 4.2 is 8. So we have 8 here. and this is equal to negative 1 out of 4. The third one was g prime of root 3. So we have negative 2 out of root of 3 cubed. So this is equal to, remember, root of 3 cubed is root of 3 times root of 3 times root of 3. This multiplying this, we just have 3. Now 3 and times root 3, so we have 3 root 3. So we have negative 2 out of 3 root 3. And this is our answer as well. So you can leave your answer like this, or you can rationalize it anyway, it's fine. I hope this also better explain the concept. Now let's look at some challenging question over here. We have to find the derivative and then find the equation of the tangent line. At the indicated point. So we have y, which is the same as f of x. This is equal to 8 out of the square root of x minus 2. And we have to find the equation of the tangent line at 6, 4. So with this question, first of all, we have to find the derivative. So derivative, we know, is the limit as h approaches 0, f of x plus h minus f of x out of h. So first of all, we have to find f of x plus h. So when we come over here, we just have to replace x with x plus h. So we have 8 out of x plus h, then minus 2. So we can rewrite our f prime of x to be limit as h approaches 0, then x plus h minus 2 minus our f of x that was given in the question, then out of h. So using the same idea as we've been doing, we have to find the LCD in the numerator. So in this case, we just have to combine both terms, right? So we have this multiplying x minus 2. So this 8 will take this value, this 8 will take that value. So we have 8 multiplying x minus 2, then minus 8 also multiplying root of x plus h minus 2, then everything out of h. Now remember, this is not like the previous example that we did over here, right? You see this right here. In this case, you have a radical form. And remember that I said whenever you have a radical form, you have to find its conjugate. So in this case, we have to find the conjugate of our expression. So if we are finding the conjugate of the expression, all that we have to do is to change this sign right here to positive. So in this case, we have 8 root of x minus 2 plus 8 x plus h minus 2 out of the same thing, right? So now what we have to do is, since the radical, remember I also said that if the radical is in the numerator, then we have to expand the numerators and leave out the denominator. So in this case, we have to multiply this term right here by this using the FOIL method, right? So this by this, then afterwards this by this. So if you multiply the first two terms, we're going to have 8 by 8 is 64. Then this times this, the square root vanishes. So we just have x minus 2. Now you multiplying this by this and this by this, both terms cancels out each other. So you're just going to have the last two terms left. So negative 8 by 8, we have negative 64. Then the square root vanishes, so we have x plus h minus 2. In the denominator, we leave it as it is. So in this case, we have x plus h minus 2, root of x minus 2, and also we have 8 x minus 2 plus 8 x plus h minus 2. I hope this is clear enough. Then everything out of h. But remember, instead of writing everything out of h, you can just have multiplying 1 over h. So we can go ahead to expand the parentheses. So in that case, if we expand, we have 64x, this times this, 64x times this, that is 128. So we have 128 here. Then we expand the second parenthesis, we have 64x minus 64h, then plus 128 out of the denominator. So clearly, we can see that this cancels this cancels this. So we have our f prime of x to be equal to limit as h approaches 0. In the numerator, we just have negative 64h. In the denominator, we have everything. So we have this, this, and this, and times 1 out of h. So this h will cancel this h right here. So now f prime of x is limit as h approaches 0. In the numerator, we just have, let's just evaluate it, right? In the numerator, we have negative 64. In the denominator, as h goes to 0, this goes to 0, and this also goes to 0. So for the first parenthesis, we have root of x minus 2. The second one, there is no change in that. For the third parenthesis, we have x minus 2, no change. In the second one, we have x, then plus 0, minus 2, so we have this. So our f prime of x is minus 64. Now if we multiply this and this, the square root goes away. So we have just x minus 2. And now if we add this to 8 plus 8, that is 16. So we can have 16, then square root of x minus 2. So let me copy this right here. So we have this. So we can rewrite this as negative 64. We can bring the 16 outside. we can have x minus 2 and the square root of x minus 2. So 16 goes into 64 4 times. So we have our f prime of x to be equal to negative 4 out of x minus 2 and now the square root of x minus 2. So this is the first derivative. Now, after finding the first derivative, the question is asking us to find the equation for a tangent line. Now remember, equation for a tangent line is basically, let me write this, equation of a tangent line, that is y minus y1 equal to m x minus x1. In this case, we will have our m to be the slope. So to find your slope, you have to evaluate f prime of x at the x value that was indicated. Remember, we had a point 64. So xy, so we have xy to be equal to 64. So in this case, we have to find f prime of x, which is just 6. So that is minus 4 out of, now x is 6, so 6 minus 2. We are using this right here. And root of 6 minus 2. So this is minus 4. 6 minus 2 is 4. And root of 6 minus 2 is root of 4, which is basically 2. So this just simplifies to minus 1 over 2. So this is our m, our slope. So now we can go ahead to do our substitution. So we have y minus, now y1 is this. So this is y1, so we have 4. Our slope, we had negative 1 out of 2. X minus, now x1 is this, 6. So now using this, we can just cross multiply, right? So this 2 multiply everything on the right hand side, left hand side. So we have 2y minus 8. Then negative x, we distribute the negative 1 over here. So we have negative x plus 6. Then we make 2y the subject, so we have negative x. Now, if 8 crosses, it becomes positive, so we have plus 14. So to find y, we have to divide each term by 2. So we have negative x out of 2 plus 14 out of 2. So y is equal to negative 1 out of 2x plus 7. So this is the equation of the tangent line. I hope this video explains the concept very well, and you can use this to solve many questions regarding finding the derivative of the first function using the derivative approach. So thanks for watching. If you find this video helpful, give it a thumbs up and share it with your fellow calculus enthusiasts. Don't forget to subscribe to Dan is Math for more math content that breaks down big concepts into simple steps. See you in the next video. Keep learning and keep solving. Bye.